All right, this is Pre-Calculus B, Unit 6, Lesson 6, Modeling Linear and Projectile Motion. You're given some formulas in this unit, but really it's best to think in terms of resolving vectors into their horizontal and vertical components. So here's a problem, a situation. We have an object at a location on a coordinate grid. We'll call it P aught. And P aught is 3, 7. Okay? And that object is going to travel at a consistent speed, consistent velocity, velocity having magnitude and direction. And the velocity it travels at is going to be let's see here. It's going to be 8 meters per second. 8 meters per second. Okay, that's the magnitude of the velocity. So magnitude of velocity, 8 meters per second. And it's going to have a consistent velocity. It's going to travel steadily at that rate. Okay, and it makes an angle with the horizontal, of 25 degrees. Okay. And we want to represent this situation with parametric equations, x and y components. Okay, so it has a y component acting in the vertical direction, and it has an x component acting in the horizontal direction. So think in terms of vectors, think in terms of resolving into components, horizontal and vertical. Notice that this makes a rectangle, which is also a parallelogram. Okay. And we can use a little bit of trigonometry to find out the horizontal and the vertical components of the vectors. So the velocity in the x direction, is going to be 8 cosine of 25, because cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse. So take the diagonal, multiply by the cosine of the 25. And the velocity in the y direction, and actually it should be vector symbol there. Velocity in the y direction is going to be 8 sine of 25. Okay. All right. So what's going to be its motion given relative horizontally and vertically? I'm going to use parametric form. So I'm going to use coordinate form. So I'm going to give an x-coordinate, comma, and a y-coordinate. Okay. So the horizontal motion of this object can be modeled by 8 cosine 25. That's the steady velocity that it's traveling at, plus the starting horizontal position, 3. Okay? Whereas the vertical component, the vertical motion, is going to be 8 sine 25, plus the initial starting position vertically, 7. Okay? And that's where these formulas come from. V cosine theta times t, times time, right? T and t, times time. Let's clean that up. 8 cosine 25 times the amount of time. So every second, it's going to travel 8 cosine 25 in the horizontal direction, t, plus the initial position horizontally, 3. And 8 sine 25 times t plus 7. Okay? So the formulas given in the lesson are v cosine theta times t plus v aught, or plus x aught, the initial x position. Okay? And v sine theta times t plus y aught. where that's the x aught, y aught is the initial position horizontally and vertically. Okay. All right, so in this question, we're asked, what is the position? What is the position at 5 seconds? Okay, so here we go. Let's go ahead and model this using Desmos. Okay, so we're going to model this using Desmos. 8 cosine 25 times t, comma, plus 3, comma, 8 sine 25 times t plus 7. Okay, for t equals 1. Okay, t equals 0 to 1. Let's go to 3 seconds here. Let's see what this does. Start graphing horizontally, so something's wrong here. 8 cosine 25. Let's try putting parentheses around cosine 25. Cosine 25. Oh, there's what's wrong. I missed the t. I put a 5. There we are. Plus 7. Okay. And why is it going down? 8 cosine 20. Oh, because I did one, and make sure of this. If we're entering degrees, make sure your calculator's in degree mode. There we go. All right, there we go. So this models the position over time, and we could check out what happens from 1 second, 2 seconds, 3 seconds, 4 seconds. Okay. All right. And so at t equals 3, so t equals 3, then this position is going to be, let's call, I wonder if Desmos will do this. P equals, and P. Now, it labels it. Actually, here we go. No, it doesn't give me the actual values. So I'm going to have to enter the values. 8 cosine 25 times 3 plus, or times 5 plus 3. And 8 sine 25 times 5 plus 7. Okay, so 39.3, comma, and 23.9 is the final position. Okay. All right, and this has gone a little long, so I'm going to make a second video for the second one. Now, the second example is an object that is under vertical motion under gravity, the acceleration of gravity. So it's a little bit more complicated. The horizontal component behaves just like this does. It travels at a steady rate horizontally, but vertically it's under gravity, it's under acceleration. It actually has a parabolic path.